This program contains experiments which are performed by professionals. These tests are dangerous and may involve the use of hazardous materials. They should not be performed or imitated under any circumstances. To amplify light, night vision goggles turn light into electricity. The electricity is amplified and turned back into light. The result? Bingo! Amplified light. The first step in the process is capturing what little light is available. That's pretty easy to do with this objective. Light passes through the first lens. Its path is slightly altered by 3 more lenses in order to limit distortion, and voila, the light is captured. Now we play a little trick on the light in order to change it into electricity, which is much easier to amplify. The special substance covering this glass disc uses the light's energy to propel tiny particles called electrons in the direction of the next disc. An electron that's propelled is a moving electron. Duh. For the record, electrons in motion are electricity. Now we're ready for the next step, amplification. The second disc takes care of that. It looks like a strainer. You may not notice it at first glance, but this disc is covered with tiny holes. In each of these holes is a tunnel. Make that slanted tunnels. When an electron zooms in, it collides with the tunnel wall. The impact yanks another electron from the wall surface, and now you got 2 electrons. 2 electrons slam into the tunnel wall, each pulling off new electrons. Now 4 electrons hit the wall, each pulling off new electrons, and, well, you see how it goes. This infinitely small chain reaction leads to gigantic results. For each electron that goes into the disk, about 100 electrons come out. More electrons means more electricity. The task now is to change more electricity back into more light. A phosphorescent substance absorbs the energy of the electrons to produce particles called photons. Photons, by the way, are a fancy name for light. Green light. Why green and not blue, red, yellow, or orange? Green's the color of choice because the human eye is especially sensitive to green. The resulting light is 25,000 times brighter than the one that